afternoon, everyone. Thank you very much for joining this workshop on semiconductors. So you saw from the title, we talk about the Chips for Europe initiative because the quest in semiconductors for bringing research closer to the industry needs is addressed very clearly in the European Chips for Europe initiative, which is an important pillar of the CHIPS Act. So that's what we will be discussing today. And today we have a very interesting list of speakers. We have Martin Sauer from Bosch. We have Thomas Weleweins from VOC Sense. We have Joe DeBuc from IMEC. And we have Silvana Muscella from Allpros. And before I actually give the floor to the panelists, I would like to make a short introduction on the CHIPS Act, and in particular on the first pillar of the CHIPS Act. So if I can see my slides, please. Okay, so let me start by reminding why we put up the CHIPS Act in place. When we thought about putting the CHIPS Act in place in the European Commission, we were during COVID period, and at that time there were many shortages for semiconductors. I think shortages for semiconductors were also present before, but during COVID they were particularly remarkable, and that really was evidence for policymakers of the importance of chips for our economy and society. I don't need to tell you they're pervasive as a technology, otherwise it wouldn't be here today. But what is important today is that the CHIPS Act still matters a lot because at the end of the day, we may not have COVID anymore at the moment, but we are subject to some very important geopolitical tensions. And I think that it is a geopolitical context that is really giving a lot of flavor of meaning to the CHIPS Act today. Not only we are in a complex geopolitical context, but we are also looking at an increasing demand for semiconductors in the next decade, which is going to be very important, and for which all companies are preparing because, of course, this also comes with a technology shift. I remind you of the technology shift that is taking place in artificial intelligence, for example, and that will really be driving a lot of the evolution of the application of chips also into the systems of the future. Now, the CHIPS Act has 3 pillars. The first pillar is what I will analyze more in detail. It's a Chips for Europe initiative, which gives a name to this session, and it's about a new program of the European Union with a total from the European Commission of about more than 3 billion euros, which is going to be matched by the investment of the member states. And if we take it all together with investment of the Commission and the member states in the R&D and innovation program of Europe, we reach about 11 billion euros until 2027. And the second pillar is rather more about making Europe a more attractive place to invest. So we are in an important geopolitical context. We have companies that find themselves in important international value chains. It is important for us to be able to strengthen in the European Union our capabilities, in particular in terms of manufacturing of chips. And it is for this reason that we have adapted some of the European rules to facilitate also public support to investment in the Union. And until now, I would say since we adopted the CHIPS Act, we have planned investments or announcements for investment in the European Union of about 100 billion euros. And then the third pillar is about increasing coordination with member states. So I come from the European Commission, And of course, the European Commission works in close contact with member states. We already did that in the area of research, but now we also do it for the policy making in the area of chips, including for international matters. And so we gather in a semiconductor board, which is made with member states and which also had an important role to play for all the policies that go beyond research and that concern risk technologies and, as I said, international affairs. But let me look into the first pillar of the CHIPS Act, which is called the Chips for Europe initiative. So this is really the program that we designed with the idea of bringing research closer to industrial needs. Because Europe is very good at research. We have excellent research and technology organizations in Europe. We have excellent universities. But now we really have to facilitate the way this research output can reach, let's say, the industrial level. And so we have created a number of actions that are connected into the drawing that you now see on the slide. We, for example, first of all, already started investing in pilot lines. Pilot lines are kind of infrastructures, as we call them, that are supposed to facilitate the testing and experimentation and even the prototyping of designs in the European Union. And for this, we are counting on our major research and technology organizations to put them in place. We also looking at the setup of a design platform because in the European Union, we really need to strengthen our capabilities in design in this area. We have a very small market share at the global level, like 1% or even less. And, but there are a lot of SMEs and a lot of startups that are active in this area. And so with the design platform, we really want to help to reduce the cost for these kind of players to come into the market. And this is linked to the pilot lines because, of course, we will also facilitate access to the PDKs, for example, of the pilot lines. Thirdly, we want to facilitate access to this infrastructure, pilot lines, and design platform across the European Union. And so we have proposed to member states to set up competence centers across the Union. This means identifying at least one organization in each country that can really be a focal point for all the relevant actors, whether these actors are SMEs or startups, whether they're universities, or even the user industries, because of course, all these changes in technologies and AI that I was mentioning before, these are also bringing very important needs at the level of the verticals. And so we hope that the Competence Center can work as multipliers of the access to the central infrastructure we would like to create and really facilitate and nurture, basically, our ecosystem. They will also be very important providers of training. And we intend to spend a certain amount of budget together with the member states also from this point of view, because we all know that talent is short, and we'll also talk about this today. And then last but not least, we have also set up a CHIPS fund. So we have, through InvestEU and through the European Innovation Council, we try to provide seed money in particular for the startups, early stage, but also more mature that would like to scale up in the field of semiconductors. For the pilot lines in particular, we have launched a call. It's our first call of this program. And we foresee, and we hear more about this, the setup of 4 pilot lines. A pilot line on FD-SOI to go down to 7 nanometers. Then we have a pilot lines on advanced chips for less than 2 nanometers. And then we have the heterogeneous integration system pilot line, and then a 4th pilot line on wideband gap, and basically facilitating also innovation for materials and new materials. So we think that these are the 4 main areas, and in the future there is likely to be one or two more areas where we find it very interesting to put on pilot lines. These are the ones that we called now, and so maybe next year at this time we'll be able to give you more information to see where we are in the setup of the pilot lines. For the design platform, as I said earlier, we are looking at helping SMEs and startups to use tools to maybe have the possibility to have more interesting licenses, for example, with design tool providers, and also meet and have access to also open source tools on the platform. So a set of services that can really help SMEs and startups to reduce their cost in design, and if in the future also helped by the support of member states, for example, be able to thrive in this particular sector. Competence centers, I was mentioning earlier. Here we are talking about technology organizations, or likely to be RTOs or universities, who are able to help SMEs, startups, other universities to access pilot lines or design platform or give advice on the basis of their own specialization. So we are giving a lot of importance to the competence centers, and the member states are seriously looking into this. They will be making the selection, and the idea is to come up with a network of competence centers in the European Union so that they can also refer companies to or universities to each other in the network and exploit all the different specializations at hand. The implementation of this initiative in the European Union is with the CHIPS joint undertaking. This is like an agency of the European Union that is in charge of managing our program on semiconductors. So they publish the calls, and as I said, the ones on the pilot lines have just been published, but this year we will have another pilot line, we will have a call for the design platform, we will have the competence center. So I invite all of you to pay attention to this, but also to pay attention, if you're interested, to the research program of the joint undertaking. I have not mentioned it, but there is a Commission and member states together more than 2.5 billion euros for research and innovation, and there are calls always published by the joint undertaking, and I invite all of you that are interested to participate. So this was my introduction on what is the CHIPS for Europe initiative, and I will now invite our speakers to come and tell their perspective in terms of bridging the gap between research and the industrial world, and they will certainly make reference to some of the elements I mentioned. I would like to start with Martin Sauer, Dr. Martin Sauer. He comes from a leading company, Bosch, which has a very rich history of innovation, and that has been at the forefront of technological developments for decades. So please, Martin, come to the stage. He's head of innovation policy and public funding at Bosch, and you will have 5 minutes. Thank you.
Thank you so much. Thank you so much, Lucilla. I would like to basically in my presentation cover 3 things, 3 pillars, you could say, like in the CHIPS Act. First of all is, of course, the most important, say thank you for inviting me today. It's a pleasure to be here and to be able to explain what Bosch is doing regarding semiconductors and chips, and where we are, so to say, touched and influenced by the CHIPS Act. My second pillar is, of course, to tell you something about Bosch, what we are doing. And third of all, I would like to express my dedicated thank you to the Commission for putting in place the CHIPS Act, and of course explain to you a bit more in detail why this is an important instrument for an international company. So let's start by telling you something about Bosch. Probably Bosch dishwashers, washing machines, wipers, things like that. But that's not all we do, of course. We are the company is divided into four sectors: mobility, industrial technology, energy and building technology, and consumer goods. In Bosch Mobility Electronics, ME as it is abbreviated within Bosch, we are dealing with semiconductors and chips. The headquarters of Bosch Mobility Electronics is located in the southwest of Germany, and there is, of course, not only Germany and the headquarters, there is an international network where we are producing, testing, and of course also collaborating with research and others within Bosch and within the network. You know probably some of our sites, like in Dresden, this plant was funded by the IPCEI instrument, the Important Project of Common European Interest. A couple of years ago, we bought a fab in Roseville, California last year. But we are also producing and testing in Asia, for example, so it's a worldwide network. As you can imagine, of course, being the world's biggest supplier for automotive, there is a lot of automotive when Bosch and microelectronics come together. I don't want to go through all of this with you, but just to give you an impression where in a car you can find Bosch products and Bosch semiconductor technology, you know, this is a very good overview. And this is, you know, to some extent understandable. What you probably did not know until now is that Bosch semiconductor technology has also left our planet. There is, I think 3 years ago, there was the NASA Ingenuity Mars helicopter, which was stabilized by Bosch sensors. So in order to be able to fly self-propelled, it needed this Bosch sensors to be stable. And you know, that's something which makes us proud, of course, as a company, and it's a good example for tech leadership and you know, what you can reach with Bosch technology. That was Bosch, you know, the second pillar I wanted to touch. Of course, we are here to speak about the European Chips Act. And as I told you, there is, of course, and as Lucilla already introduced, there is international competition regarding semiconductors. And this competition is basically done by investment, by incentives, of course, but also by investment. And until we got the CHIPS Act in Europe, it was really, you know, harder to get funded and to get support than in other regions of the world. And this level playing field internationally now is strengthened quite a lot by the European Chips Act. Why is it so? Because as today we're here to talk about from lab to fab, globally, the R&D environment is really competitive, and in Europe especially, we have a comparative advantage since collaboration from industry with R&D and with society, of course, is working very smoothly. The green transition is catalyzed by semiconductors to a certain extent, since sustainability and the component level is quite important. Lucilla already touched the skills scarcity. That is something which is of great importance for us, you know. Also from regarding talent, there is international competition. We at Bosch lost our plant manager in Dresden to TSMC just recently. So there is competition, which is good for the people, of course, but for companies, you know, it's a resource which is not there at the moment. Internationally, we are lacking hundreds of thousands skilled labor for the semiconductor business, and that's, you know, something we can now engage in much easier. What is, of course, also true is that, you know, the aim of the CHIPS Act is not to follow what is be done internationally, but to be a leader, and to be a leader in semiconductors and to make Europe an attractive location is something we have to work on all together, and that is also mirrored by the CHIPS Act. So that was my short presentation. I'm really looking forward to our discussion. Thanks a lot.
Thanks a lot, Martin, for the good presentation. Let me say, however, that innovation in Europe does not only come from the big players, it also comes from smaller players. So I would like to invite on stage the Belgian company VOC Sense. As the result of more than 15 years of research in the university laboratories of UC Leuven, VOC Sense is developing a new concept of an environmental camera, allowing us to see and detect the invisible chemical and biochemical molecules that surround us. Please welcome the CEO and co-founder, Dr. Thomas Ballevens.
Thank you for the introduction. Thank you for inviting me. It's a great pleasure to be here today. So, of course, compared to Bosch, we are like the mouse seeing the elephant. Maybe we can fear the elephant. We'll see in the future. But let's introduce VOC Sense. Okay. Yeah. So yeah, as explained, our mission is to make the invisible visible, to contribute to the health and safety of people and ecosystems. I will do short introduction by we are part of a European event. So by joining here, a big issue facing the world and especially tackled by the Europe is the gas emission control and the air quality management, who are become major global public health and economical challenge. So it concerns legislation which is more and more repressive regarding emission of, for example, ammonia, nitrogen, methane. For example, in the agri-food, it's a big issue, but also largely in the recycling and chemical. And currently, there isn't any easy to integrate, reliable, and cost-efficient solution for such monitoring. So that's what we developed at VOC Sense. It's really a new concept of environmental camera. The difference with a classical camera is that we have a CMOS chip, like a CMOS camera, but we put sensing materials on top of the pixels, like in the previous electronic nose, let's say, and these multiple sensing materials are sensitive to specific gases or gas family. So we developed a patented process placed onto a classical transducer array, and then we combine that with some AI-based algorithms for data processing in order to provide our customers with the actionable insights they need regarding the gas concentrations. So how it looks like, you see it, it's about 10 by 5 square millimeter chip, which have specific, I will not go into detail, is advantages in terms of being multi-gas regarding specific markets. So if you look to emission, it allows you to monitor ammonia, nitrogen dioxide, and we are working on adding the methane also on it. What we have also, it's a quite long autonomy because we reduce a lot the power consumption. So it means that we target at least 10 years operation lifetime, and that's for the main advantage here of the component. So to put a link here with the CHIP Act, we come from a university, so this process and this product has been first developed at UC Leuven. It's a university in the south of Brussels, Louvain-la-Neuve. It's the equivalent, French equivalent of KU Leuven in Flanders. And so this process was first developed on small 3-inch wafer. And so we worked for the last year on the industrialization on 6-inch wafer before moving to 8-inch, so 200 millimeters. So that's a lot of challenges. And in fact, one of the main, I hope, advantage of here the CHIPS Act will be really to facilitate the industrialization of a new process by getting direct access to industries, to not only to small pilot clients, but big players with facilities in Europe, allowing us to directly have a learning curve by doing our industrialization process and scale up. Then, behind that, we, so that's to enter onto the targeted market, so starting from the agri-food and recycling, smart building, chemical, oil and gas. But what I wanted to mention, so here is, for example, the interest of such small systems. You know, in Flanders, for example, but everywhere in Netherlands, Germany, we face, for example, issue to mitigate the ammonia emission. Before mitigate them, you need to monitor them. That's the first steps. And here you see an example between a classical bulky and expensive analyzer, about 50k euro, more than 50k euro, and an affordable solution, so taking into account the integration on a dedicated hardware. And then you see here, for example, the comparison between our microsensors and the analyzer, which fit quite very well the response. So that's some facts and figures about our company. So we have been founded 5 years ago. We have in total about 6.4 million financing, with about 30% of dilutive part. We have a strong ecosystem related to research. We are now moving, and it's one of big challenge to validate our business model with main industrial player, because we are fabless. So that's important to be able to really industrialize at mass scale or process, being about 20 employees. What I also want to add and to conclude is also the importance of the facilities regarding the design tools. We work with Europractice, with a 2-year program, which stopped now also. So that's also a big interest for us to be able to continue our R&D and especially our development by having the help of Europe is this part. And then to conclude, our vision, helping the world become more sustainable. That's why it's important now, not only regarding the climate change, but all the pollution-related stuff. Thank you for your attention.
Thanks a lot. That was really interesting. And now we move to another issue, which is the issue of the workforce and of the talent that we need in the European Union for working in semiconductors. And it's an issue that is very common in the digital sector in general, but I think that in semiconductors it's particularly acute. So to bring the perspective here, we have invited Silvana Muscella. She's the technical coordinator of allpros.eu and founder of Trust IT Services. Silvana.
Good afternoon. Thank you, Lucilla. Thank you for the opportunity. And I'm an SME. How many other SMEs in the room? Put your hand up. Are you part of an SME? Okay. Oh, there are a few there. So I have a staff of about 50 people, of which I have 10 who are under 30 and 6 who are under 25. And they were inspirational, actually, for me in giving me insights for this talk today. Now, those who are under 25 are all undergraduates. Now, my company, it works in digital. We are an ICT company. And the undergraduates are full-stack developers. And this is quite novel in Italy. And I have permanent collaborations with the University of Pisa, Bologna, and Polimi, Politecnico di Milano, who we often have interns. Now, the reason I wanted to start with this, I wasn't going to, but I thought this is really cool, and I love that we do this. And my CTO says he wouldn't know what to do if he didn't have these undergraduates working with us. So I wanted to start with that opening bracket. All Pros, as Lucilla described, is a DEP, Coordination Support Action. We're in our second of 36 months, so we have another 2 years to go. If we are a facilitator project to support Europe in strengthening visibility and showcasing what's happening in semiconductors, and we've worked pretty hard in the first year, and already we have online an opportunity for organizations, SMEs, mid-caps, large industries, to actually focus on their products and assets. So Voxens, we will be talking to you after, because we'd love to obviously showcase what you're doing in the marketplace. Clearly, we're not going to become another Google, but what we want to do is obviously tap into the TRLs of specific companies, those cool companies doing stuff in Europe that people can go to All Pros and actually see and find, obviously, other market opportunities for uptake. We work also on delivering a TWG. You see the acronym, and what we're going to focus on today is our thematic working groups. And we have one launching very, very soon on skills. So this is why I'm invited here too. You see the partners at the bottom. IDC is actually the financial coordinator. My company is the technical ones, and we're supported by OFE and White Research as well. So numbers. From Statista, you will see that we're in pretty much dire straits. We heard already from Lucilla before. There is a gap, there will be a gap of 350,000 workers as the talent is increasing and it outpaces the talent supply. I actually saw somewhere 500,000, so this might actually be out of date. 70% of global semiconductor manufacturing still based in Asia, predominantly in Taiwan, but also China and South Korea. What do we want to do in Europe? And it's already happening. And what I wanted to provide here with this slide is just a bird's eye view of initiatives that are happening to help bridge the skills gap. We heard before about the CHIPS JU. There's the EU CHIPS Skills Academy, the EU CHIPS Skills Alliance. There are a number of other projects, some that are kicking off already in 2024 that are going through their grant preparation phase, so can't be mentioned here. But there are all of these different activities. What we don't want to do is clearly have fragmented parts, and we want to try and funnel these efforts into one channel, if you like. But already we're seeing that there are obviously, well, and some would argue they've been going on for years, industry-sponsored courses, or there are summer schools, shared curricula. And Europe has a huge, rich cultural strength of regional cooperations and integration. So this is something that we really need to work on and can work on successfully in the future and bring all these efforts together and that everybody knows about them. Before I conclude, a couple of points from adversity to prosperity. So the global issues that are taking place at the moment, we're seeing these, and there's the other session over in the auditorium, tackling AI, but the interconnectedness is here, dealing with novel technologies that are interconnected also with AI and edge, and this is something that we clearly need to integrate as part of the discussions going on with semiconductors. Europe needs to invest its unique strengths, and we have to learn to be more adaptable and resilient. So our solutions, what we're proposing, is to help target the structural unemployment with a constructed effort working on the triple helix approach. So I've got my academia, my industry, and my governments working hand in hand together. I have two girls, 18 and 16 and a half. The 18-year-old is currently in her final phases of trying to understand, what am I going to do when I finish high school? And it's great talking to her at the moment, and it's also a struggle because I don't tell her to go online and look at the university courses there. She wants to do something in STEMs, which I'm really happy about. But most of the courses haven't been revised for the last 20 or 30 years. Why would I send her to read them? She's going to be bored after the second sentence. So who are we influenced by? Our parents, our teachers, our influences. Whether we like it or not, you're going to go on TikTok and Instagram and find people on there. So my point is, if I send my daughter to an open day with a university, I don't want her to just have a university professor sitting next to her telling her about biomedical engineering. I want to have the industry sitting next to the university professor who tells her what kind of cool job she can do if she studies the course, because that will help her then make more informed decisions for herself. And this is what is lacking. So this is what a triple helix approach absolutely needs. And we need to be speaking to our 15, 16, 17, 18-year-old students out there. So join us, and this is something I'd like us to discuss further in the panel, on delivering a blueprint that can provide these types of guidelines. And if you're interested in joining the thematic working group, please call out to us at All Pros. Thank you very much.
Thanks a lot, Sylvain. A triple helix approach is always interesting to understand better. I hope we have the time to do that in our session. Now, we are in Belgium under the Belgian presidency, and of course, we are going to have IMEC with us. This, as all you know, is a very important research and technology organizations from Belgium, but from the European Union most importantly. And IMEC has always been very instrumental in exactly helping to bring research closer to industry. So I would like to welcome on stage Gio de Boek. He's the Executive Vice President and Corporate Strategy Officer for IMEC.
Thank you, Lucilla. Thank you. It's a compulsory act in Belgium, apparently, but I'm glad to be here. Most excited about the panel and the messages that were given already earlier. I think the gist of what we try to do is bring technology leadership even stronger and build on our strengths in Europe. If you look at the pyramid, or inverse pyramid, if you want, of technology development, you can see nothing, basically. It builds up while we speak over a number of different layers, and I think that's also what we've seen displayed on stage already today. There are people like VOC Sense looking at these very smart applications to change how we act with the world. These would be sensors that feed in information. You need algorithms. Before you know it, you're very deep down into the stack because they're looking at technology and technology innovation. The point I'm trying to make here is that if you want to really innovate and do it fast, you need to accelerate the connection through this ecosystem. This is what we typically are doing in RTOs, but it's also what's happening in companies, and I think that's where we need to join forces. Joining forces, indeed, in setting up new technologies, making sure that there is a lab-to-fab transition from the breakthroughs in academia, where hero devices or new materials are being built, do this in an industry setting, but also allow the application builders to access it very, very early on. This is where the pilot lines would come in. This is what we're looking at, combining the technology development in a very early phase also with the design and the product innovation community. This is where you can build new demonstrators that you can go to pitch to venture capital or to your internal CTO to make sure that in-company or new companies innovation can come to market. This is typically what can then happen. The question, though, is how do you get from the initial idea really to the scale? And also, that was mentioned earlier, you need, for certain companies that are ready to scale up, you need the access to the full ecosystem. These will be people that allow you to build a more stronger algorithm, so the more ICT community and looking at AI aspects of things, but also, of course, the makers, the ones that will provide you the scale that you need with your chips or with your products in the same way. So I think going through this is where also the competence centers, as they have been mentioned, could benefit from connecting to each other, making sure that their local strength is translated into something that becomes a European strength. And that chain of innovation is often broken for small companies because they can't see end to end, but is also maybe slow in large companies because they have a certain product vision they need to adhere to. And so in that sense, breaking open that innovation cycle, making sure that the fastest route is being presented to all of the innovators, professors, students, but also senior researchers and even product developers alike would be the mission. To round it up, this particular slide has been presented in another format by Lucy before. So I think we're looking at having a system where there's a lot of interface planes. People can meet, can talk about their disciplines, can also enthuse and inspire each other about what is possible. These would be communities that are typically very strong in the technology, but also the ones which are somewhat colored in the more design community. And often designers are very distant from technology innovation, and that is a gap we definitely need to bridge. We'll come back to that, I'm sure, in the panel. So if you look at opportunities that you could find in the ecosystems, this slide gives you snapshots of where you can bring people together. It's on training, it's on entrepreneurship development, it's on opening up to a VC community, it's making sure that that capital market becomes more European and not just in one region only, and there's many more things that will connect the technology to the innovation in Europe. That's what I wanted to show at the start of the panel, Lucy. Thank you.
Thank you very much, and I would like the speakers to come on stage, please, because now we are going to have a panel. I will sit at the end there. Please sit in the rest. Thanks a lot. So I would like to start, now this time I'm going to start from you, since he was the last to speak. So can you indicate to us what do you think are going to be the main technology trends for the next 10 years? So as we build innovation to be brought to the market, what are the main trends we have to be careful with?
Yeah. So don't base any investments on my comments. No, I think. Well, we all know AI, and I think the first thing we should say is there's a lot of new waves coming in. I'd like to focus that and keep it short. Of course, it's going to change the way we do compute and to change the ways we do many things. I think the very important challenges or trends we will see is to infuse that in domains where we less expect it or already see it coming. Healthcare would be one. I hope it also fosters acceleration on the Green Deal. And also maybe the way that we just go about our daily lives in cities, in mobility, all of that will be that edge AI component that we will see coming in, moving it from the cloud to our day-to-day practice. So.
Thanks a lot. And what do you think from the side of Bosch? Would you agree with that analysis?
Yeah, I totally agree. AI is really important for a company like Bosch, not only as a user, but also as a investor and developer. We just participated in a financing round for an AI startup in Germany, 500 million euros. At the end of last year, which was also produced quite a lot of media attention. Other from AI, there is, of course, hydrogen technologies, which are really important for us, stationary as well as mobile applications. And there is quantum technologies, not only quantum computing, quantum sensing is something where Bosch is heavily engaged in. So I think these other two technologies, apart from microelectronics, of course, probably make, round it up.
Thanks a lot. And I also take the opportunity to remind that as part of the Chips for Europe initiative, we will also be supporting pilot lines in quantum. So I think the role of chips in quantum is going to be very important indeed. Silvana, you mentioned this triple, how is it called? Triple helix.
Triple helix approach.
Yeah. Can you tell us a bit more about that?
Well, I think credit goes to the EU STEM Coalition, because they were the ones I spoke to a while back, and they were saying that they were working on this. I said, oh, well, can you explain this a bit more to me? And basically, we have the three elements of academia, industry, and governments working hand in hand to help support bridging the skills gap. Now, there are some fantastic examples already in Europe. Some are more advanced, some less advanced, who are already doing this. And I saw already, IMEC, you've got things on your slides. So I'm not saying anything new. What's important is that how these are effective hasn't been showcased widely enough. And so it's important that those countries who are doing an extremely good job on bringing together, changing curricular course, thanks to industry giving recommendations on what their needs are in industry, and universities responding by saying, okay, well, let's do something about this, and then having government come in and actually support from a financial point of view. It's something that should be rolled out on a Europe-wide approach and learn from those best practices that are already out there. I talk about universities, and I go back always to my daughter of 18, and I know that things are already happening in high schools. And I think that is also an important factor to home in. We're not just talking universities here, we need to go a step further back, because I see the gaps that my daughters have and would like to already be able to know that there's someone an effort in place that they can seek out and find from research, academia, and industry, all see the bigger picture altogether, which is nice.
So Martin, as a large company like Bosch, probably, as you said it yourself, short in talent, what can you do to convince the daughter of Silvana to undertake the studies and maybe join Bosch?
What we do is of course, offer attractive jobs and attractive salaries, but we have to start very early in the educational life cycle, so to say. And that's what we are doing as Bosch, so as a company alone, but also via industry and employers associations in Germany. They go to schools, to high schools with, for example, it's called in Germany info trucks, where young people can try out things which then, can become a job. So they can do experiments regarding different technologies we offer. The metal and electrical engineering industry, where Bosch is also a part of in Germany, finances these things. They are quite expensive and fully booked over a year. So that's what we do together with other companies and together with industry associations. What we also do is, of course, finance professorships on universities in fields which are of importance for us, like, for example, microelectronics, but there are also others. And we, of course, also collaborate quite closely with universities in order to attract talents when they, try to specialize in a certain way, and then to make them aware that Bosch is not only an automotive company. And I have to admit that Bosch is really, successful in finding or building fabs in places that cannot be reached very easily. So, we have to do that. We have to do that extra effort in order to attract people.
So good luck.
Thank you.
For that. Thomas, for you, attracting talent must also be very difficult, but also I would like to know, what about attracting other kind of capital, not only human, but also funding? How difficult is it in the European Union in this particular sector?
First, to add a point with the talent, I will say the employees, so we have the chance being near an ecosystem with a lot of universities and high school to be able to have master students, PhD students, to convince them to work with us and then to attract them within the company. So that helps, of course. Also, when we are smaller, we have a motivating project. And regarding the attracting the money, I will say, having also a motivating project with behind a real impact is important. And so that's the first things that we need. And yeah, in Europe, the ecosystems, we have the chance to have really nice investors trusting to us. So it was not so difficult to reach and convince investors. Now what is most difficult is with the money to be able to, not to attract them, but to convince to stay, because we need now to prove our business model. And when you have a business model which is not only related to sales, but based on a fabless production at semiconductor level, it required partnership with foundries, with industries, bridging the gap between the research and the industry. And that's where we need some help, because indeed, in Europe, it's really not easy. And even could say, okay, you have IMEC, which is not just 30 kilometers away, but in Belgium is a lovely country, but sometimes crazy, because you have to know that it's as difficult to work with IMEC than with France or Germany.
Okay. Did you know that? It's probably maybe you would like to add to this.
No, I think he's right. He's totally right. So I think, and it's just not within Belgium. I think in Europe we need to lower barriers between countries, specifically for the small startup companies. And you are in a fabless community, so you don't need to necessarily carry the load of doing the actual manufacturing within the company, but you have quite a bit of deep tech startups, which are a whole different branch of needing to just not develop the technology, but also make sure that it translates and goes into manufacturing, and typically also owning part of that IP. So they can go to companies like Bosch that enable that as well, or TSMC, but we need to broker around that quite a bit. And in order to do so, you need hefty capital. I hear high numbers saying you're investing as a corporate VC in companies that go beyond the 100 million in terms of one round. I mean, you're now at 6.3 or 6.5, if I recall well. Next phase could be 10 or 50, and then you need the investors coming from abroad, so to speak. And let's make sure that in Europe we connect that capital market closer. I think the CHIPS Act is actually doing this with the Deep Tech Fund, infusing capital into the market, but it's an effort we need to play at a different level. Yeah.
Indeed. So now I would like to see if there are questions from the floor that you would like to ask to our panelists. We have a microphone, so yes, we have a question here. Please introduce yourself.
Okay. Enrico Borella. I'm doing a lot of things. I'm a consultant. I'm a mentor for startups. I wanted to ask the panel, to each person, what's the single most important thing to achieve? Maybe utopia is independence on chips manufacturing in Europe, but let's say a good percentage of locally sourced chip instead of imported, because I think it's a strategic goal. So yeah, that's my question. Thanks.
I'm not in the panel, but I just want to clarify, we're not trying in Europe to be self-sufficient in the production of chips. We're just trying to become better and strengthen our capabilities in the different areas, but it's not about becoming self-sufficient. But still, who would like to start? You would like to start? We'll go in order.
I was going to say what you said just as first, right? We need to make sure that we have a very strong international ecosystem. Having said that, I think already answers part of your question. Then the next question is, what is going to be critical for European markets? And I think there, it is going to be a combination of many technologies. I think that's one thing that we need to come to understanding broadly. So there will be companies that build the eyes and the ears of the internet that's going to be perfusing in our daily lives. But also that leads to decision-making processes that are either very close to the user or very deep into the cloud. And there's no single application in the future that will not rely on a chain of technology. So we are going to be critically dependent on quite a few technologies, and having global partnerships, global relationships, global footprint, as you saw from the Bosch footprint, is really global. Most European companies that have a play have that global footprint, and vice versa for non-European companies. So we should realize that building these interrelations with like-minded countries is going to be the way forward, and then making sure that we have the innovation power to not let go of critical assets in that chain. So of course in Europe we have ASML as one example for the suppliers chain. There's quite a few examples, maybe not of the same magnitude as ASML, but very, very important there. We have the tiers companies. Bosch is a very keen example there, connecting applications with very specific and very high quality products and technologies. But we'll have to have also the design community being very close, as I mentioned in my pitch, very close to these new technologies that are going to come up out of these, for instance, pilot lines or other collaborations. So a very lengthy answer to say we need all of the above, I know. But it is important that we start to connect really throughout the value chain and making sure that we understand all disciplines throughout.
Thomas?
Yeah. So if I can add also more from an economical point of view, if we can identify businesses, especially sustainable businesses, where we can really work on, for example, the whole post-process, maybe having the CMOS part coming from either Europe or elsewhere in the world, but we can really produce high value-added product, for example, in clean tech, in health tech. It would be, at an economical point of view, very relevant for Europe to have this power than to provide chip in this relevant sector.
I think, first of all, that goes a bit in the direction of the colleague from IMIC. We have to make the European ecosystem work. So it's not that one country, and I say that as a German, has to benefit from the semiconductor industry as a whole and from new fabs and so on, but we have to make the European ecosystem work. So there has to be cross-border interactions, there has to be testing facilities close to production facilities and so on. That's the first thing. And the second thing is that we need public funding. So it's an international level playing field and competition taking place there. I hear that every now and then that there has been so much public funding for microelectronics and the semiconductor industry. Do you really need more? And the answer is yes, because looking into other regions of the world, like the US or South Korea or others, they are funding heavily. So if we want to, not only reach the goals and the targets we are now aiming at, which are quite ambitious, but at least stay where we are and build up on that. The answer is yes, we need public funding.
Thank you. Silvana, you will...
Yeah, well, touching upon, I can't obviously compete with these answers. Touching upon the utopia point you mentioned, and I think what I said before, Europe has such great strengths in terms of, collaborations, integrating together. Just look at the whole concept around European Union funded programs and projects with fantastic people from all over Europe working together. So that should be the push that helps us become better, because we're learning from each other countries' expertise and experiences. And the competence centres, for example, could be one avenue where that excellence is pulled together.
Thank you. Is there another question from the audience? Okay, I don't see any hand raised, so we'll ask a question. So in this context, where we are trying to bring research closer to industry, looking at the Chips for Europe initiative, are we on the right track, and what more could Europe do? I don't know who would like to.
I think that Europe is on the right track, because we need funding. So Europe is bringing these funds. So what could maybe be attractive is maybe have also being able to empower Europe as an industrial player, and not only at a research point of view, but really with being conscious that Europe is also a main industrial player over the world, and then maybe by having these companies, these industries being able to work for Europe, also with this mindset, being European.
You have also mentioned, Thomas, you have mentioned the design platform before. So as an SME or startup, what do you, how are you going to make use of the platform, and what are you looking for in that platform exactly?
For all the development, so all the software for electronic design, it's very expensive. I will not tell the cost, but it's about the order of 100,000 euro a year. For small companies, for just small development, so we had the chance to be able to work with Europractice, so with a 2-year program. Now, as I explained during my presentation, it will be finished this year. So if we have the chance to be able to benefit for the development of our next product to such a platform, of course, we will be really happy to be able to not expend 100,000 euro, but maybe only 10 or 50,000. So similar to what we pay as part of the Europractice program.
And for you, Martin, as a big company, I mean, our programs, pilot lines, design platform, target smaller companies in reality, but for you, what is the channels through which we can bring more research to the industry?
From a company's point of view, you know, the answer is quite easy. It has to be a positive or attractive business case. And attractiveness is determined by certain factors or boundary conditions. One we spoke about today is talent. One is political stability. You know, it's not there in every part of the world. One is money, of course, and one is the ecosystem. And the ecosystem, so the close collaboration with research facilities, with unions, with industry associations, you know, that forms an ecosystem in Europe and also across European borders, which makes Europe an attractive location. So I think that's key.
And Silvana, for you, I mean, is research and industry competing in reality for talent? How can we make sure that it doesn't become a negative competition, but a relationship that nurtures both sides?
Well, I probably would quote maybe something I heard this morning in the plenary. I can't remember the lady's name. The whole part of impact and taking the results from research to deployment, and that when you see that happening, then you see that as a success. When a project finishes and you don't just put it in a shelf and then go on to the next thing. So. I think that's becoming more and more important. The question is, well, can you just tell me exactly how this is impacting society? Going back to the talent pool and trying to find people and talking to my under-25s and it was really interesting when I asked them, you know, what are you looking for in a job? And I don't know if we can link this to research, but it's nice. They said, well, you know, I want to find out whatever I'm studying, that it will give me a job. So that's the first thing they think of. What's going to give me money? What's going to make me fulfilled? And how am I going to make an impact to society and to sustainability and worrying about climate change? So I thought, and that, you know, really determined answers, and they were all the same. And I thought, well, I certainly wasn't like that at that age.
Not working more than 35 hours per week.
No, but sorry, Lucilla, but I wanted to also ask, can I ask a question?
Yeah, sure.
When I said at the beginning, oh, you know, the open days at universities and they're talking about the courses, I'd like to hear your opinions, you know, especially Bosch, IMEC, when, you know, do you often go to to open days as well and showcase things in simple terms that someone of 17 or 18 can really understand?
Yeah, even more so deeper into the education system. So we have more than 20 years now a program where we deliver, you know, teach the teacher and packages for the classroom at the elementary school level.
Oh, nice. So
the important part of that is to make sure that they early on get inspired, but also we need to help the teachers in elementary school to talk in an inspired fashion about this technology, which is actually part of the bottleneck, right?
Yes.
And so the teaching community and all throughout has been a constant focus, and we need to still continue doing that. That's what I'm sure we can talk after the session about how to expand that further in Europe. But of course, often it's very regional. It's language, you know, controlled. It has to be infused in the teaching or the vocational schools, etc. So all of that is a process of investment continuously. But indeed, and connecting, I think that's one important element for the youngsters today, is connecting what they do in their job or day-to-day to the planet, right? I mean, we hear this everywhere. And also making them aware that when they use their smartphone, they're actually consuming as much power as a refrigerator, right? They need to understand, you know, what is happening with technology and maybe demystify a bit.
Precisely. Sorry.
And, maybe.
I just wanted to add one thing. I mentioned it earlier that we are doing such things as Bosch as well. and on our own. So we go to universities, especially as a company, and we fund industry associations, for example, to do these groundwork at elementary schools, for example. So we see that this is really important and pays out at the end of the day. We rely quite heavily still on clusters which are there, which have been there for decades. Take, for example, Saxony, which also during the German divide has been quite successful in semiconductor industries. And we still see that these clusters work. So we try to strengthen also these clusters by then engaging locally in industry networks and things like that.
If you allow, I'd like to balance that with regions that have more of a challenge than Saxony and Saxon-Anhalt. I was actually last week in Croatia signing an MOU to collaborate with their competence center through the pilot line. I think Lucy will be happy to hear that. But if you look at those, any Croatian in the room? Okay. So then she or he can correct me, but I think they lost about 20% of their active young population by immigration out of the country, right? So we need to find ways to make sure that these people either come back or that they stay for purpose. And that purpose needs to come from, of course, some inspiration, as we just said, but making sure that they get exposed to where technology's options are, I think is very, very important. And of course, we're talking to Dresden, but we should also talk to Zagreb and talk to Sofia and talk to Bucharest, etc., etc.
And I was getting to you before about the same question I asked them. So what is the key to bring research to the industrial needs? We are on the right track, I think, with the CHIPS Act, but what more would you have done?
Well, congrats with the CHIPS Act so far, but I think we need to make sure that we keep the speed and the pace and make sure that we are continuing to lead the pack on that innovation investment. I think it's important to connect the industry and the innovation very early on. So every instrument that we have or put in place should make sure that there's a very early benefit of making sure that we go step by step together. And there is subsidy, of course, needed also, because you're playing a game which is before the market opens up, so typically kind of hard for listed companies or even companies of a size of any size, but that are instruments that you have in place in the CHIPS GU, make sure that we can connect the industry very early on that innovation. And then, of course, investment in startups, because I do believe these are the ones that can Schumpeter the market, making sure that there are, through merger and acquisition or becoming unicorns, whatever route they choose to take, that they have impact. So these are the two elements. Going fast side by side and having investments for the youngsters, I think, is essential.
But coming back to the startups, I hear most difficulties to become a scale-up and to become an SME and then a larger company over time. Is this an issue for that in your opinion is due to what? To lack of funding, lack of talent, lack of market access? What is the real difficulty in this sector in the Union now?
So first, what I see here is very encouraging because, we have the funding. If we have such a new call, quite similar to, for example, the EIT Accelerator program towards scaling up, that can be a real impact for the semiconductor startup companies, and that can help us also to raise money for Series A fundraising, for example, above 10 million by mixing public and private funding with the help of Europe, because of course it's a lot of money. If we think about 10 million fundraising, we can imagine to have between 2.5, 5 million by co-funded by Europe. So that's very nice instrument that we can put all together. And then behind that, this is what I said earlier, is really the access to pilot lines, but not only pilot lines, the pilot lines directly related to an industrial player. In our case, we work on a new process, so it means also investments for an industrial partners to develop this process and to produce our microsensors. And so that's need investment in a win-to-win approach. So that will be challenge for the next years, but I think that we are in the good direction.
I wanted to add one aspect, and that aspect is that we have to be careful not to lose out of sight the needs of the industry. You know, innovation is of course good and beneficial, and there can be also business opportunities come along with innovation. But when when there's nobody who's buying it, then the money is lost. So you always have to take into consideration what the industry needs, and for example, take into account semiconductors. At the moment, the automotive industry needs mature nodes, so when we create production capacity, this has to be in focus. And it's always, at the end of the day, someone has to buy it. Otherwise, companies will stop doing it.
Yeah, but I would argue that it is in focus at the moment. What we are asking companies to do from the point of view of the European Commission when we allow the public funding is that even production of mature chips is somehow innovative compared to what we already have in the market. And I think this should be very important also given the competition that comes from the rest of the world. And I'm sure you are, as a company, very attentive to that. But I had another question for you relating to the scale-ups. And because we heard before you saying, hoping, that maybe they get acquired from other parts of the world. How do you see the role of European companies in investing in these startups and helping them to gather capital for their work? So what is the role of industry, big industry, in this semiconductor ecosystem?
I think, and I have to be careful now, I think our role is quite important in supporting these SMEs, doing what they do quite successfully when they develop, because they can act much faster and much more, probably more and more highly innovative than big companies do, because bigger companies are always bounded due to quite a lot of processes, due to our ways of decision making being so long. And SMEs, for example, are able to act faster, to adapt faster to new market conditions, and that is then where our big companies can learn from, probably collaborate, maybe buy. So I think that's what their advantage is.
Yeah. Now, before we close, I would like to, because we are about to finish the time available, and I have one more question for each of you, and I would like to give you a minute to answer. Now, I am a director in the European Commission, responsible, among other things, for semiconductors, so we'll have the possibility to influence the next commission, which come into being at the end of this year. What would you, and so I have the possibility to tell them, well, this is the next policy you should put in place in the area of semiconductors, or this is the one action you should put in place that is going to be really important for the future. So what would you advise me to say?
Keep going, that would be the one thing to do, because we just started. And if I look, since we are here in Belgium, Flanders has been putting 40 years of commitment after or behind IMEC. I think that's the route the Commission should continue to take. So keep up the pace, I would say.
Silvana?
Basing your previous comment on getting the message out also to your colleagues in Croatia, etc., I would strongly suggest that the skills gap and triple helix approach is embedded in each competence center in each European country.
My advice or my wish would be stay ambitious, and look for the right conditions to make semiconductor industry in Europe a success.
Maybe look on specific sector, work on it, so choose them and work on it by putting the money on some dedicated sector with high potential and working on that. So Europe is quite engaged with all the sustainability related stuff, the clean tech, everything. So maybe choose this target segment and put all the effort on it to have a real impact.
Thank you very much. So with these nice messages, I will close the session. Thanks to all of you for having followed, and thanks to all the speakers for their intervention, and let's give them a round of applause.